Okay, so before I start going through like the way I set this up and kind of go through it, do any of y'all have any questions to start off with about what you're going to be presenting with emission spectra?
Okay, so the way I talk about it is I'll just start with drawing two energy levels and an electron, and I talk about how the atom will absorb energy and the electron is going to jump to a higher energy level. That's at the excited state. And then when it moves back down to the ground state, that's when the atom releases the photon, and that's the light that we see.
Yep.
And depending on how much the properties of that wavelength, energy, frequency, that depends on the color we see.
Awesome. So that's kind of the way I start. Could you grab a marker?
Yeah.
So I have this drawn in Expo, or not Expo, in Sharpie, and that way I can like use this over and over again every year. So I've got like a class set of these, and I've just taken 2 or 3 of them for different demos I do throughout the year. So just take this, and I drew 5 circles. You can put all 6, but it's not that big of a deal. And what I usually start off talking to them about is I remind them about, hydrogen has 1 electron when it's in its ground state, and it starts off here. And so I'll kind of like draw the little electron down here in its ground state, and we'll talk about, okay, it's there, but what you don't know is they can be excited. And so what I'll generally do is when I start talking about that, just to kind of get them jazzed, is I'll put the little spectra tube in here, and I say they'll get excited when you give them energy, and so you turn it on. And they're like, whoa, and they get really excited about it because it does something. Like, okay, well, when the electricity started going in there, we see the change, what's going on, and that's where I bridge into like what you were just talking about. Is I'll say, okay, if you put atoms into a situation where they're exposed to electricity or they're exposed to heat, we're going to be doing the flame lab in our class, and so I say, hey, on Wednesday, sweet. So y'all can say, hey, next week on this day when we're doing our lab, and you guys are going to be putting wooden splints into the flames. It's the same as this. That's what's going on. That way they got like something concrete to like attach it to.
Okay.
And so then I'll say, okay, so if it absorbs maybe a little bit of amount of energy, maybe it makes a small jump up in the cloud. And it really doesn't matter like if you make it 1 jump, 2 jumps. Just let them see sometimes you've got a small jump. Other times that electron can make a very large jump in the cloud. And so you gotta let them kind of digest that and let them ask their questions. And then you say, okay, but here's the deal. When they go up there, they're excited, but they're going to make their way back down to where they belong eventually. And so, I kind of show them, okay, whenever they come back down, they can't take all that energy they absorbed with them. They have to get rid of it somehow, which is what we're seeing. And I connect it back to this again. That's what we're seeing right here. Is that when they go back down, they can't bring all that extra energy with them, and so they release it as photons. Now generally I give like a little squiggle mark or something in their notes that they can kind of follow along with and see it's the fall. It's when those electrons move back down, that we're getting something that we're seeing here. So far, anything that's off?
So like when we're calculating, I think I may have asked you this already. The amount of energy that they're absorbing from the electricity or the fire is how much they're going to release in the photon. Are those always equivalent?
Yes, they're proportional.
Okay.
So the next thing I bridge it into is just that, where I'll talk about, okay, so what did we see? We're looking at this and we're seeing a color, and then the next thing that I'll do is I'll say, okay, you saw how one of these did a little jump, and one of these did a big jump, so they should be releasing kind of like different amounts of energy. And I'm like, but when I look at this, we just see one color. And they're like, oh yeah, well, they come up with different explanations, and then I like blow their minds with this. You put this in front of there, and it breaks, you say, okay, this is a prism. And there's a couple more if y'all want to look. But this is a prism, and it's breaking up the light that we're seeing into all the different kinds of lights that are blended together to get this. And they're like, oh, and they're freaking out. They're like really excited. And then here's where I make my connection back to, okay, we talked about the electromagnetic spectrum. What colors do you see? And they're like, oh, cool, I see a bright red band, and I see a green one, and I see a blue one. I'm like, that's awesome. Which one of them has the highest energy associated with it? Which one has the least? And so a lot of times they'll have to get their notes out because they'll have to kind of double check and be confident. And so they'll go through and they'll be like, okay, the red was the least amount of energy on the electromagnetic spectrum. And the blues and the purples, those are the most. And then that's when I have them come back to here and say, okay, we've got this knowledge that we learned earlier. We know that the electrons are doing different sizes jumps. I said, I'll end up saying, okay, which color do you think is associated with either the big or the small jump? And I usually switch it between different groups that I talk with, so they can't just like listen and get the answer from the last group I talked with. But then they're like, okay, well, if it jumped just a little bit, if there's just like little bits of jump, then that must be a small amount of energy, so that goes with the red. And then they're like, okay, so the blues and everything that are high up, that's a lot more energy, so that has to go with the bigger jump. And that's just kind of relating like what you've talked about into what they're seeing here. What else?
Do certain elements do only certain jumps?
Okay, so every single element is different from every single element. It's a huge, really complex thing that not even my AD students actually have to understand. What they have to understand is that every element's different.
Okay.
And each element has different bands that it produces. If you've got that kid who's like asking you like, come on, give me more, what you can say is, well, it has to do with how many protons are in the nucleus and how attracted are they to the electrons around it. Every time you add a proton, it's a different relationship. And that's why you have different bands. I actually have a couple different ones for us to look at. We use this one first, and one thing that I would point out for y'all when you're in your classroom is this is air, which has carbon dioxide and nitrogen and oxygen, all kinds of stuff, and look at how many bands are in there. I mean, there's a bunch of different lines. And so I would point out that because there's so many elements in this, we see lots of different bands that represent lots of different jumps. But then the next thing I would do is throw in the helium, and I would recommend using this one in your class because this has the most distinct bands out of any element that I've done. It's just 4, and they are like absolutely crystal clear separate.
Does that mean that it only makes 4 jumps?
4 jumps that your eyes can see.
Okay.
So our eyes have such a narrow band of what they absorb. These are the 4 jumps that we can see, but if it made an even larger jump, that would come out as ultraviolet, and it would give you a sunburn, but we wouldn't be able to see it.
But bees can.
But bees can. And then infrared heat's another one. If it's a really small jump, then it's possible that the photons that it would produce are below what our eyes register. So another nice thing is when you turn this on, they're like, oh, it's different, because they're like, oh, okay, I get it. Like, this is a different element. And you can connect it. I would highly recommend connecting it to different signs you see at gas stations, because they think, oh, they're all neon signs. No, some of them have helium because they're this color. Some of them are white, so it's a different element. Only red ones are neon, and so that's kind of a cool connection they can make to like world around them. So then you split this up, and you can see the bands super clearly. Like, I mean, it is 4 distinct, separate bands. And they're like, oh, wow. And you're like, well, this is just one element. And so you've got, just a few different bands, a few different types of jumps that our eyes can register. And then you can go through and have them talk about, okay, the blue one has the most energy, the teal one has the next, the yellow one has the, lower, and then red, in this case, would have the lowest amount of energy and the smallest jump. Any other things there you've got? Go ahead.
I'll go really quick. So we do the flame test.
Okay.
And we are looking at metal ions.
Yes.
So, and they're in compounds, but it's the metal ion that's producing the flame color. Okay. But that every time I test that, I'm seeing like one color. So how do we like talk about like comparing that to like this and these bands?
So you can talk like this is different. Well, I'm gonna say it's the same. So like if helium's clearly not a metal,
right?
But I would say I've got one in my room, and when you do this for mercury, you get this beautiful like blue color like that.
The lightest.
Yeah, and I would say that if you burned mercury in a flame, which that's kind of apples to apples, metal to metal. I would say mercury would have to have a flame something like this. We can Google it in a minute and just check and see if that's right. I'm not like telling y'all big fibs. But that is my, as a scientist, as someone who's done this in class, that's my prediction, is that since mercury is that color with the electricity exciting the atoms, those same atoms in something else, like a flame, should produce a similar color. Good?
Right. Yeah. Okay. Can any element be subjected to more energy and make different jumps? So if you put more electricity or more heat, would it jump more and give you a different color?
Here is my educated guess of what was going on here. We have umpteen jillion atoms in here. Because I don't know if this is a mole or half a mole or a third of a mole, but even if we have a fraction of a mole of helium inside of this, there's still a absolutely enormous amount of atoms inside of there. And inside of that huge sample, there is going to be some atoms that are gaining a little bit of energy, some that are medium, some that are more, some that are large, some that are excessive. And so I would say since we have such a large sample size, probably almost all of the possibilities of absorbing energy are present here in those bands. And like I said, if we had if we took like a camera that could register infrared or ultraviolet, there's more bands. Like we just can't see them. So I guess I would say that this is showing you all that there is, and if you used a higher voltage or a hotter flame, I don't think you'd see a significant difference.
Okay. I was just wondering about that. Clearly I'm not going to talk to my student about that. But
One of them will ask.
Yes.
You've always
Exactly. I want to
There's
understand
always
it.
one student.
Okay,
Because,
so
Yeah.
this, we're looking through this,
Mhm.
and we're seeing all the colors that the atoms are making. That's what the bands are showing us.
Yes, and they
But when we take
represent-
this away, our eyes are just seeing one color.
we're just getting it all together. So it's just like these lights, like this white light is a blending of like a
All the
plethora
photons
of
that are
different
made.
colors together. It's the same thing here.
Okay.
This like kind of peach that we're seeing from the helium is just a mixture of all the colors and all
the
those bands together.
Okay. So in the flame test, are we seeing a mixture of...
Absolutely, you are.
Okay,
and if
but-
you took one of these,
So is it that accurate when we're like, well, that flame was blue, so I'm going to go to the EM spectrum and I'm going to calculate based on blue? That's not really accurate.
I tell my students all the time that
It's
teachers
just for
tell them
practice.
95% truths to teach them something, and then we can fix the 5% exceptions afterwards. This lab that we're doing is a 95% truth. Because if we took this to the flames that they're seeing, copper green, and you put that up,
You're going to see bands.
there would be bands.
Okay.
But
Should we do that with them?
how complex do you want to make it? Because to me, what is the point of the lab? If the lab is, doing some chemistry and understanding which colors have more energy just by the color, it doesn't matter that there's multiple bands in there, because they can say, okay, this was green. I know that green photons have more energy than yellow photons. I'm going to, assume this wavelength and do a calculation, and it serves the purpose of the lab at their level.
Okay.
And then if you've got that kid who is pushing further, that's a great extension you can do.
Okay.
And say,
yeah,
okay,
'cause
hey,
I'll
check
probably do
this
that
out.
in tutorials
'cause-
because I can already pick out 2 or 3 students
Oh,
that I
yeah.
know are going to be like,
They're
but what
like-
about this?
You're like, but we saw that earlier, and say
Yeah.
that's a great connection. Check it out. Take this, go do the green one, and watch. And they can be like, wow, there's these 3 different things that are mixing together. But again, that's beyond the scope of what y'all are trying to accomplish with this first lab.
Okay.
Anything else?
Okay, the flame itself, the fire, is that not also atoms? Like, that has color.
Hmm?
So that's also
The only
Photons being
the only
released.
reason that we're seeing a flame is because of this. And the reason, like an orange flame, if you strike a match or like a lighter of butane, the reason it's an orange is because there's impurities in it. And those impurities are radiating a lower energy photon. Whereas if you have a very clean burning flame that has less impurities in it, you get a blue and if you think about the connections you told about your students, oh, you want to go to that bright blue cone in the middle. Why?
that's the hottest.
But why? How do you know it's the hottest? Because it's the brightest blue color. It's higher up on this spectrum that we're talking about. And so that's why that little blue cone is the color it is. It's the highest energy.
The Bunsen burner,
Yeah.
the methane there's the atoms that's happening just in your flame.
Mhm.
And you're using that as the energy source to excite other atoms.
Mhm.
So this is making photons, and we can see this color, and we're using this to excite these atoms.
You're not necessarily using the photons.
You're
using the
using
heat from the
the heat,
fire that
okay.
is also producing the photons
Okay.
that you see in the fire.
I had a grade B kid ask that today. He's like, yes. Yeah.
Anything else?
Is this a periodic trend on the periodic table? So when we do that salt lab, are we tying that back to the periodic table?
I'm gonna give it a big fat no because
Okay.
We tie it
you will regret trying to do
I
that.
would tie it back just to the atom and how the electrons are moving, since that's how I fit it into
Okay.
this unit.
Here's the deal. I got a postcard from a company like last year that if y'all have a kid who's doing that, text me and I'll send it to you. It's a periodic table and it has every single atom, the spectra, in the shape of the periodic table. So you can look through and see the spectra bands for everything.
That seems
But there
It's
is
pretty cool.
So it's free?
Yeah, they sent it to me, they were like, buy our stuff. Here's a little sample. I'm like, thanks for the little sample. I'll put that on my wall.
Yeah. So there is a trend, but we're not teaching them. Is that?
I would say it's very hard to establish a pattern with the spectra bands. I would definitely make the connection that the more electrons there are, the more possibilities for jumps you have. Perhaps the more bands you'll see. But as far as, the alkali metals are going to be this color and...
Well, like as you go across the period,
That's right.
the atomic radius is smaller.
Because there's more protons in the
So they're
nucleus.
going to be less likely to let go of those electrons?
And all of that plays into the bands and why they are the way they are. But I'll be honest, I have never had the need to go through and establish, because this has 7 protons versus 8 protons, you get this. It's beyond the scope of anything I've ever had to try to show my students.
Gotcha. Okay. So just tell them.
I would just say that each element is unique. It has a unique spectra because of their protons to electron relationship.
Gotcha.
Okay.
But for my own curiosity.
And that's going to have to be on you. Like,
Okay.
literally, I don't know is the
Okay.
answer.
Okay, so
sorry, I'm
when
sorry.
you do this in class, like you have things like this?
What I did, I taught this 2 days ago. And the way that I teach my students is I do this on a practice day. I've done a whole day of teaching electromagnetic spectrum. Then we do probably like 10 minutes of practice at the end of class. When they come the next day, we just continue practicing. And what I'll do is I'll kind of break the class up into small groups and I'll pull them out 6 at a time. I usually do it in the back of my room. But I'll be doing this with a small group like this, and everybody else will be practicing their assignments.
And then just
It takes me about 5 to 8 minutes to do this presentation for my students. Send them back, next group. Send them back, next group.
So
It's
you
nice.
only need like one
Yeah.
little sheet.
Okay. Literally, this is a very good example of what it looks like in my class. I usually have about double this amount of people, but this kind of an environment, this kind of a questioning session, showing them stuff. I pretty much walked through what I did with my students. So what you guys have just been through is what I teach.
Awesome.
Okay.
All right.
I'm excited to teach it.
Awesome.
Yeah.
Okay, so this
I like
is
this
able to connect electricity. It has like a wire.
I remember doing this
Yeah,
in
and
chemistry,
this-
having no idea why. Like
Some
she
sort
had
of an electrode.
8 different
Okay.
Basically,
tubes.
there's such a small amount of gas in here that when the electricity starts going through it, ionizes the gas and carries the current through there.
Okay.
All right.
Okay, thank you.
Yeah, thank you.
Awesome.